This is lesson 7 from the using units of measurement topic, and this one is going to be looking at how to use volume and capacity. The learning goal is to look into the link between volume and capacity, and the success criteria is to connect volume and capacity and their units of measurement. Now with this one, there is a bit of confusion and it does get tricky towards the end of this skill with the questions, and that's mainly based on this unit conversion here, which shows you a volume of some sort, whether it's cubed centimeters or cubic meters, and the conversion from one to the other in regards to milliliters, liters, or kiloliters or megaliters. And it's hard to know which one of these you have to use, and also in conjunction with the conversion from milliliters to liters to kiloliters to megaliters. So you have to be smart and logical with the approach to these type of questions. So the first question for this first example here, which measurement shows a volume of 15 cubic meters as a capacity? So this is saying of some volume of some sort, regardless of whether it's rectangular or cubic or whatnot. If you were to get the volume of this volume is 15 cubic meters. So length times width times height, when you multiply it all together, it will give you a cubic meter area of a cubic meter volume of 15. Now we're trying to figure out what's this as a capacity in regards to liters. So we can fill this up and have a certain amount of liters in there, but how many liters can we put in there? And this is tricky because, well, we need to figure out which one of these out of these 5 will help us out. Now we know that we're looking for liters, and we can see here that 2 of them have to do with cubic meters, because our answer, what the volume is being given as a cubic meter. So we have to use one of these 2. Now, obviously, don't necessarily care about kiloliters, because none of the answers provided within the multiple choice is kiloliters. So it can't be this one. We have to use this fact here. And this is saying if 1 cubic meter is equal to 1,000 liters, then how much will 15 of these cubic meters be? Well, that, to get from here to here, we're just multiplying it by 15. So I guess what we need to do is just do the same on the other side. We just have to multiply 1,000 by 15, and this will give us 15,000. So 15,000, and specifically 15,000 liters, is our answer, meaning 15,000 liters can fill up this 15 cubic meter volume. So be careful with how you approach this, because some of the questions in relation to this can get quite tricky. Now we'll look at another one to help us out. Here, we're going to convert this volume to the unit of capacity shown. So we have 2,500 cubic centimeters, and we want to see how many liters can we fit in that. Well, what we do know is that 1,000 cubic centimeters is equal to 1 liter. So 1,000, and there are different approaches to this. There's more than one approach to this. So if we know that 1,000 cubic centimeters will give me 1 liter, we need to figure out what 2,500 cubic centimeters will give. Now to get from here to here, we're multiplying it by some number. Now this is where it gets a bit tricky for some students, because they're like, what do we need to multiply this by? We're not multiplying it by 2, because that will give us 2,000. We're not multiplying by 3, because that will give me 3,000. So it has to be in the middle of 2 and 3, namely 2.5. So if we're multiplying this by 2.5 to get how many liters we need, we also need to multiply this by 2.5 as well. And 1 times 2.5, well, that's just 2.5. So 2.5 liters is the amount that will fit into 2,500 cubic centimeters. So again, you got to be smart with how you use this. You got to make sure that you use the correct one. Another way you could have approached this is we know that 2,500 cubic centimeters is going to be equal to 2,500 milliliters because they're exactly the same. And then you would just change 2,500 milliliters, which is here, and change that to liters. And to do that, you just divide by 1,000. So that will be 2,500 divided by 1,000, which gives us 2.5 again. So there are different approaches. However you find easy or easiest for you and see how it fits, go for it, as long as you are getting the correct answer. You're then going to get a few questions that look like this. Which container has the greatest capacity? By capacity, it's just talking about which one of these can hold the most of some types, maybe volume or a liquid or capacity of some sort or mass. We need to find out which one can hold the most, which one has the greatest. So in order to do that, there are different ways. You can do the tedious long approach, and you can see how many squares go widthwise, how many squares go lengthwise, and you can count how many would be on the base. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you can count it again: 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Keep going until you get eventually what your volume will be. Or the other way to do this, which is a shortcut method, and that's what math is all about, is you just find the length, find the width, and find the height, and your volume is just length times width times height. And this will tell you how many cubic, whatever this unit is, let's just say centimeters, how many cubic centimeters will fit into each of these containers. So our length in this case was 4, our width in this case is 3, and we kind of already figured out that the base amount is 12. So we know that's 12 on the base, and then another 12, and then another 12, and then another 12. So this 12, or 4 times 3, gets multiplied by the height, which is 1, 2, 3, 4. So on our calculator, we would just do 4 times 3 times 4. And this would be 48. So this volume of 48 means that just 48 of these little centimeter cubes can fit into here. And so you would just work out the volume for this one. This is a 3 by 3 by 1, 2, 3, 4, 5. So 3 by 3 by 5. 3 times 3 is 9. 9 times 5 is 45. So 45 fits in this. This is a 4 by 3 by 1, 2, 3, 4, 5. This is a 4 by 3 by 5. So we can do maybe 5 times 4, which is 20, and 20 times 2, which is 20 times 3 rather, which is 60. And then we have a 3 by 3 by 1, 2, 6. 3 by 3 is 9. 9 by 6 is 54. So which one has the biggest volume? This one here. And just be careful, some of the questions might say greatest capacity, some of them might be the least amount of capacity wise. Just be careful with those type of questions. Next one, which box has a capacity of 80 blocks? So again, we're just using the volume equals to length times width times height again. But this time we want a specific answer of 80. So this is 1, 2, 3, 4, 5 by 1, 2, 3, 4 by 4, 1, 2, 3, 4, 4. This is 5 by 4 by 4. 5 times 4 is 20. 5 times 4, 5 times 15, 20. 20 times 4, 20, 40, 60, 80. That's the one there, our first one. You can go and double check to see, make sure that all of these ones don't give you an answer of 80. You have effectively just already worked it out. And the last question. What is the capacity of a tank in liters if it holds a volume of water of 2 cubic meters? So remember, we'll need that trusty conversion chart to help us out. There we go. So we're looking for 2 cubic meters. So anything to do with cubic meters that transfers to liters. Again, it's this one here. So if 1 cubic meter is 1000 liters, well, 2 cubic meters must be 2000 liters. So my answer is 2000 liters. So a lot of the questions have to do with converting some type of context from one unit to another unit. Remember, you've got this little conversion chart here to help you out, which can be found in the Learn Me tab on the side. And that's it for this skill. Go ahead and attempt it, see how you go, and I'll see you in the next video. Bye-bye.